Today we're going to look at prime factorization of numbers. Our goal is to write a number as the product of prime numbers. What does that mean? Well, we need to apply previous knowledge to our understandings that we're going to be maintaining in a few minutes. This lesson is going to help you with the standards of the Common Core number system dealing with greatest common factors and least common multiples, which are going to be lessons following this one. We're going to begin by looking at our vocabulary: prime number, composite number, prime factorization, and factor tree. I'm going to give you the definitions and make sure you're ready to write down your vocabulary. So now I want you to take a minute to copy down your vocabulary words with the definitions. A prime number is a whole number greater than 1 whose only whole number factors are 1 in itself. In other words, it can only be multiplied by 1 in itself. A composite number is a whole number greater than 1 that is not prime. Basically, composite is the opposite of prime. Prime factorization is an expression where you use a whole number as the product of only prime numbers. And we're going to look at examples of these in just a minute. Finally, a factor tree is a diagram used to write the prime factorization. So go ahead and take a minute to pause this video to copy down your vocabulary. Now that you've finished copying down your vocabulary, we can move on to the first examples. Let's look at this word problem together. Field trip. A science class of 30 students is on a field trip at the zoo. The teacher wants to break the class into smaller groups of the same size to observe the reptiles. Find all possible group sizes by writing all factors of 30. So let's first underline or highlight the important information. We know we have 30 students, and they need to be smaller groups of the same size. And we need to find all the possible group sizes by writing all the factors. So in this word problem, they actually tell us the strategy. We need to write all the factors of 30. So in your notes, you should be writing the factors of 30. On here, I have the problem copied down for you once again. So let's start with the factors of 30. So that would be 1 times 30. And it's always nice to just go down the list. Is 2 a factor of 30? Well, we'll see. 2 times 15 is 30, so that would be a factor. We know that 3 times 10. Now we know that 30 isn't divisible by 4 because it doesn't go in evenly without a remainder. So we skip to the next possibility, which is 5 times 6. And then we notice that 6 times 5, but we can really just stop here because we stop when the factors repeat. So we can cross this one off. So our answer is going to be the possible group sizes are, so we can write possible group 1, 2, 3, 5, 6, 10, 15, and 30. So we know that she's going to group the students at least into groups of 1, 2, 3, 5, 6, 10, 15, or 30. So now we're going to move ahead and look at prime and composite numbers. So looking at the number 56, tell whether the number is prime or composite. Well, we remember that a prime number is a number that can only be multiplied by 1 and itself. Well, we know that 1 times 56 is 56. But then we need to see if there are any other possible numbers. And looking at 56, anytime you see an even number other than 2, you know that it is divisible by 2, which we will point out in our divisibility lesson, which happens right after this one. So we know, of course, 2 times 28. 4 times 14, as well as 7, and 8 are all the factors of 56. So because there's more than just one in itself, we know that the number 56 is composite. And even though a lot of you can look at that number and tell that it's composite, I want you to show me in your notes all the factors of 56 and prove to me that 56 is composite. Now let's look at another example. Tell whether the number is prime or composite. Number 11. Well, we know that the only factors of 11 are 1 times 11. Therefore, and these three little dots in mathematics mean therefore. Therefore, 11 is prime. Remember, prime numbers can only be multiplied by 1 and themselves. Now, because we are early on in the year, I want you to take a minute and review your notes, because having good notes is an essential skill. So normally I won't always take the time to do this, but I'm going to show you on the next page a copy of what your notes should look like, more or less. And I want you to check them, take a minute to pause when we get to the next page, and really look through your notes carefully at this point. So now take a minute to look at my notes that I have supplied for you. You don't have to have everything highlighted the same colors. You don't even have to have anything highlighted. I just highlighted it to make it easier to see certain things. And I want you to make sure that your notes are complete, that you have all the necessary information. And remember, at this point, your questions, main ideas, and keys and summary should be blank. Those should not be filled in just yet. Now I want you to take a minute to write all the factors of the number. Take a minute to pause the video. You're going to spend this time figuring it out for yourself, and then you're going to check your answers. So now that you've checked to practice the problems, I want you to check your answers with me. So the factors of 35 are 1 times 35, and then another one that works is 5 times 7. So our factors are 1, 5, 7, and 35. Factors of 32, well, we have 1 times 32, 2 times 16, and 4 times 8. Factors of 65, we of course have 1 and 65. We also have 5 times 13. Factors of 23, we have 1 times 23, and those are the only factors. Now I want you to look at these numbers and tell whether they're prime or composite. Well, using the information we have from the previous page, we know that 35 is prime. 35 is composite. (32) is also composite. 65 is composite, and 23, because it only has a factor of 1 and 23, is a prime number. So make sure next to each number you also write in your notes whether it's prime or composite. Now I want you to try finding the prime factorization using a factor tree. There are several ways you can make a factor tree in this example of 54, but I'm just going to show you one. So I'm going to start with 54 on the top, and I'm going to choose 3 times 18. Some of you might choose 2 times 27 instead, but either way you're going to get the same bottom line. Well, we can break up 18 into 3 times 6. Now 3 is prime, so that's going to continue with us. And again, 3 is prime, but 6 can be broken into 2 times 3. So we know that this gives us the result of 2 times 3 times 3 times 3. Or 2 times 3, remember those exponents, 3 times 3 times 3 is another way of saying 3 cubed, or 3 to the third power. The prime factorization of 54 is 2 times 3 to the third power. So when we find the prime factorization, we're breaking down the number into only prime numbers being multiplied together. So we can see here we have 2 times 3 times 3 times 3. 2s and 3s are all primes. They can only be multiplied by 1 in themselves. Remember, 1 is neither prime nor composite, so you shouldn't have any 1s in there. Let's look at another example. Use a factor tree to write the prime factorization of the number 30. So again, using a factor tree, we can start with 30, and then we can break it up in more than one way, but we'll pick 3 times 10 as the obvious. 3 is prime, but 10 can be further broken up into 2 times 5. So we have the prime factorization of 30 is 2 times 3 times 5. We have no repeats, so no exponents. I'm going to give you another example to try on your own. I want you to use a factor tree to write the prime factorization of 48. So of course, you're going to start with 48, and you're going to break it down. This one I want you to do on your own. Go ahead and take a minute to pause and figure it out. In the next slide, I'm again going to show you what the next page of your notes should look like. We've already reviewed what the first half of your notes should look like. Now we're going to look at the last half of your notes. So now that you've finished all the problems, I want you to look at the second half of your notes. Check it with mine. Again, you might not have highlighted anything. Things might look a little different. But make sure you have all of this information neatly copied down so that you can go back to your notes and use them to guide you through assignments. Again, questions, main ideas, keys, that part should be blank, as well as your summary, because we've only been taking the notes portion. So go ahead and press pause. Check your notes, make any additions or corrections as needed. Once you've finished that, you can now take a minute to ask any questions. Again, any questions you ask should be able to be retrieved in your notes and summarize your notes. Here's a good hint. Use the objective or the goal to help guide you through the summary. But I don't want you to just restate the goal in your summary. You need to provide proof that you accomplished your goal. Use an example, use key bits of information to make your summary really great. You should have 2 questions at the very least, and you can also add any main ideas, concepts, or keys. Keys would be something like you maybe put the number symbol, which I can put in there for you, equals number. Things like that. Of course, we have the 3 dots that Ms. Salvador used, meaning therefore. That's where your keys come in. So I hope this lesson helped you both with your note-taking as well as understanding prime factorizations. Our goal was to write a number as the product of prime numbers, and make sure that you check your notes, check your understanding to make sure you've achieved that goal. You've done a great job, and I encourage you to continue trying your best.